In this video, we're going to talk about rates of change, and then we'll save graphs for the next video, but we're going to focus in on rates of change. So to discuss that, we want to kind of consider an example like below, where C of T is representing the average cost in dollars of a gallon of gasoline, and that's T years after 2000. So just to kind of make that clear, that would mean then like the data point right here, that 2 for T would represent the year 2002, and then 1.47 would be the average cost of a gallon of gasoline. So in that 2002, we would have expected the average cost of gasoline to be $1.47. Okay, so suppose we're interested in looking at how the gas prices have changed between the years 2002 and the year 2009. So 2009 then would be this value over here. So we could see that 2009 wasn't the highest year listed here. That would be 2008, the year before, when it hit 301. Don't you wish, right? And we are wanting to find out how the gas prices have changed between those 2 years. So what that means then is I'd just be looking at subtracting the 214 minus 147. So that would be, let's see, 67 cents. So the gas price had raised 67 cents in that period of time, or for 7-year period. Now, what would be interesting is to see how much it grew then each year on average. So if I took the 67 cents and divided it by the 7 years, that would give me 0.096, which means that we'd be thinking of it as raising, let's round it to like maybe 10 cents. So it's about 10 cents per year. Oops, if I'm going to write the word per, I don't need a slash, sorry, 10 cents per year. That is the average change per year. So it's going up 10 cents every year. The 67 cents is just how much it has increased. Oops, I'm going to do that in green also. From 2002 to 2009. So it's a little bit more information when we understand that it's changing at about a rate of 10 cents per year, looking between those 2 years. Now, of course, depending on which 2 years we select, that might change, right? If we looked at 2008 when it hit that high, that might be a little bit of a different average rate of change. It would have been a bigger average rate of change. So what we're looking at, this rate of change that I keep referring to, describes how the output quantity changes in relation to the input quantity. So the units that we're using are the output units. So what units are on the output, what we consider the output, per input. So up here in our example then, the output would be these dollar amounts that are for the cost of gasoline. And then the input would be the years, which is why when I wrote this answer down here for the average change, I wrote it's referring to the dollars first per year. So it's the output measurement per input measurement. So that's what that was saying right there. So some other examples: population of rats increases by 40 rats per week. That's terrifying. A barista earns $9 per hour. A farmer plants 60,000 onions per acre. And then, of course, a car can drive 27 miles per gallon. So those are all examples of rates of change that we're kind of used to. What I just calculated is what's called the average rate of change. So the average rate of change is looking at the change between two input values. And it's the total change divided by, the total change of the output values divided by the change in the input values. So a way of writing this is kind of like a formula, is to look at the change of the output divided by how the input is changing. Or another way of thinking of that is taking the difference between two output values, which we typically use y to represent output values, okay? So I'm going to do y sub 2 minus y sub 1 to represent two different y values, over x sub 2 minus x sub 1 to represent two different input values. That should look familiar. That formula should very much look familiar. It's supposed to look familiar. And if you do know what it's from, then you might know what this really is also representing besides the average rate of change. Okay, before we talk more about that, let's look at an example that uses this. Let's change the years on the last example. Okay, so this time let's use 2007 to 2009, which means we're going to use this data value and this data value. Now, notice what we have chosen is two data values where we're actually going to see a decrease in price. So that would mean then these would be our X values, right? And these would be our Y values in the formula that we just wrote above. And here, let me rewrite the formula here. So Y2 minus Y1 over X2 minus X1. So I'll treat this as the first values that we're looking at and the second values. So that means that this is going to represent X1 and this is going to represent Y1. I said that right. This is going to represent X2 and this is going to represent Y2 in the formula. Okay, so then let's plug that in. So this would be 2.14 minus 2.64 over 9 minus 7, which comes out to, let's see, negative 0.5 divided by 2, which is going to be negative 0.25. So writing this using the units, since this is dollars and years, this would be a decrease of 25 cents per year. That's what the negative is representing. So it's a decrease of 25 cents per year. That's what that's really saying, which makes sense since it did go down in price. Okay, so let's extend this to a graph this time. So they want us, given this function, to find the average rate of change on the interval from 0 to 3. So what this is referring to are two different X values. So this would be like our first X value, and this would be our second X value. So our first X value is 0, that's right here. And really we'd be looking at the graph. That's where X equals 0. So X equals 0 at the point 1, 0, 1. And then X equals 3 right here, and that happens at 4. So 3, 4. So those are the two ordered pairs I'm going to use. So this would be X1, Y1, X2, Y2. All right, so now that I have that, let's go ahead and find the average rate of change. So I'm going to do Y2 minus Y1, 4 minus 1 over 3 minus 0. So let's see, that comes out to 3 over 3, which is 1. So it has an average rate of change of 1 on that interval. All right, let's try another one. On a road trip, after picking up your friend who lives 10 miles away, you decide to record your distance from home over time. So this is the recording of how far you have traveled over hours. All right. They're asking us to find the average speed over the first 6 hours. So that means we're going to be looking at our starting point up to the 6-hour mark. So those are our two ordered pairs that we're going to work with. So I'll just pull them down. So 0, 10 is the first one, and 6, 292 is the second one. And this would be my x1, y1, x2, y2. All right, so 292 minus 10 over 6 minus 0. And that comes out to 282 over 6, which is 47. Now, in terms of the units that I'm going to write, that would be, so the output units are miles. So this is 47 miles. And then per input units, which is hours. So per hour, 47 miles per hour, which if we wanted to be clever, we could just write MPH, since most of us are comfortable with writing that as well. Both of them work. Now, what's another way of writing this formula using function notation? Let's write that, because that's kind of what we've been doing, even though I've been referring to them as y1 and y2. We could also refer to it as f of, oops, sad little f there, f of b minus f of a over b minus a. So what we're doing is we're treating the ordered pairs as a and f of a, that's the y value, evaluated when the x equals a, and then b and f of b, that's the second ordered pair for when we evaluate when x equals b, and we plug it in and find out what the y value is. So that's the alternative notation. Instead of saying y1 and y2, we're using f of a and f of b, because it's matching it with the input value that we're talking about. So what's kind of nice is this notation allows us to work with even equations really easily, like this one, this function. So let's say then I want to find it on this interval. I want to find the average rate of change of this function on the interval 2 to 4. So these are our a and b in our formula. Okay. So I want to find f of 2. I'm going to find that. So let's see, that's going to be 2 squared minus 1 over 2, which would be 4 minus 1/2. And that would be 3.5. But I'll write it as a improper fraction, because I think that's going to be better for us right now. So that would be 7/2 as an improper fraction, or 3.5. I don't think that's all that offensive. Okay, let's find what happens when we plug in 4 for our b value. So let's see, 4 squared minus 1/4. So that's 16 minus 1/4, which comes out to 63/4 as an improper fraction. Now, if you aren't familiar with how to do fractions on your calculator, send me an email. I'd be happy to kind of step you through that. It's not too complicated. Or if you want to make an appointment, we can meet in my office hour, and I'd be happy to show you how to do that. Okay, so here's our ordered pairs though. Basically, we found f of 2 is 7/2, and f of 4 is 63/4. And according to the formula we had above, f of b minus f of a over b minus a. So in our problem then, that would be, we're treating 4 as the b, right? So 63/4 minus 7/2 over 4 minus 2. So 63/4 minus 7/2 actually comes out to 49/4 divided by 2, which is going to be 49/8. Okay, so let's try the next example. So for this one, again, man, I keep putting these stupid numbers. Sorry, guys. For this one, we're going to use this interval. And this time, they actually didn't give us a number for the second one. They just gave us a letter to represent the second value. So they're using A to represent the second value. All right, that's fine. I'm going to still go through my process. I'm going to find G of 0. and then I'll find g of a. So g of 0, well, that's kind of nice. 0 squared plus 3 times 0 is 0 plus 1, so that comes out to 1. Exciting. G of a is even more boring. It's going to be a squared plus 3a plus 1, and there's nothing I can do to simplify that. All right, so according to the formula then, I would do g of a minus g of 0 over a minus 0. Using the notation from this problem, the g instead of f, 0 and a is representing our two values. Okay, so here we go. We are going to have a squared plus 3a plus 1 minus 1, because that's g of 0, right? So this is g of a, this is g of 0. I don't need those parentheses. I'm just doing that to show you the two values. And then over a minus 0. Okay, so in the numerator, since I don't really need those parentheses, let me get rid of them. That means that the ones basically cancel, and I'm left with a squared plus 3a over a minus 0 is just a. And then a does, that simplifies. The nicest way of simplifying this would be to factor the numerator, factor out an a, and then cancel the a's, which leaves me with, oops, a plus 3.